Hello. In this video I'll give you a refresher course on the reference coordinate system and using snaps and pivots, and I'll show you some new ways that you can use some old tools. These techniques will come in handy for upcoming projects. One of the keys to mastering modeling in 3ds Max is to have full control of your pivots and their orientation, and that allows you to move, rotate, scale objects exactly how you want to. So let's begin with a box. And I will center it, and I'll give this a gray material and black object color. So the first thing that's important to understand is the reference coordinate system, and that basically controls your gizmo right here. So W, hotkey for select and move, E for select and rotate, and R for select and scale. And this gizmo right here is determined by the reference coordinate system. So by default it's set to view. We can also use something like world or local. So pay attention to the gizmo and notice if it changes as I change from view to world and from world to local. As you can see, it remains the same. However, if I switch to view and then I switch to the front view, you notice that the gizmo is now different. Whereas in the perspective view, X is left and right, Y is front and back, and Z is up and down. In the front viewport, which is looking at it from this angle, notice that up now becomes Y and right becomes X. So that is the view reference coordinate system. But if you change this to world, notice how now it becomes more consistent, and now just like in perspective, X is left and right and Z is up and down. So to avoid confusion, you may just want to use world in all of the viewports just to make it consistent so that you always know which direction is up and left and right and back. I'll switch it back to view for now. And let's say that I move this box here and I rotate it like so. So now notice if the gizmo changes. So this is view, this is world. Still the same, but if I change to local, notice how the orientation changes. So when using world, it always remains the same. Z will always be up, X will always be left and right, and Y will always be front and back. But the local reflects the object's local pivot, its local orientation. And orientation is another word for its rotation. So the reference coordinate system has separate settings depending on whether you're using move, rotate, or scale. Notice that for move I've got it set to local, but rotation and scale it's still set to view. If I want to revert this back to its original orientation, I'll press E to switch to rotation, and now notice these values right here. I can simply right click to restore it to 0, and now it's back to its default orientation of its rotation. Now I can move this back to the center. So let's say that I apply a symmetry modifier, and symmetry is occurring right here. Symmetry occurs at the point of the pivot. So since the pivot is right here, this is where symmetry is occurring. So by default, symmetry goes from right to left, but if you flip it, it goes from left to right. In this case, we can't quite tell since it's a simple box. If I press 1 or click on this plus, click on mirror, I can now move the mirror subobject to determine where symmetry will take place. And now let's say that I move and rotate the object. And now I apply symmetry once again. Notice that symmetry is working the same way because symmetry uses the object's local pivot orientation. And if I activate mirror, now notice even if I move the gizmo back in this direction, notice how symmetry is still working like this. It only changes if I rotate it. So I will delete symmetry for now. And let's say you want to do some modeling. So I'll apply Edit Poly, go to Edge, select, Ring, and Connect. And I'll insert 2 segments and just increase the pinch value like so. And I will also use Swift Loop to insert a loop here and here. And let's say I want to remove this geometry and have an insertion here. So I will delete these 2 polygons and then let's say select these three edges, make sure I'm in the move tool, and now I can hold shift and kind of move it here. Now notice how it's not lined up because we're using view, and view does not correspond to the object's local orientation because it's rotated this way. However, in this case, one quick workaround is to simply hold Control, convert to vertex, and activate snaps. And make sure you're using vertex snap, and now I can just snap it right here, and we can bypass the whole issue. Control A, weld the vertices, and then I can bridge these two edges. So in this case it wasn't a big deal because we can just use snap. Now I'll switch to polygon, and I'll select these 4 polygons and bevel. And let's say now I want to select these edges and move them back to get a slightly curved result here. And once again, if I simply move, notice how it doesn't quite line up. But in this case, there's also an easy workaround. We can activate edge constraints, and now if we move it this way, it's not really a big deal because it's being constrained to the edges. So it's being perfectly planar here. No issues here. And now I can move it down to get this curved result. I can turn off edge constraints when I'm done. So in this case we found easy workarounds. And let's say I want to also apply a new apply modifier, and I'll select these 2 polygons, and let's say that I bevel it out. And now what I want to do is bevel around this direction, but if I simply use the view reference coordinate system, I can't really quite get the result that I want. So the reference coordinate system can be used not just when you're rotating, moving the object and scaling it, but also as you're modeling. What I can simply do is switch from view to pick, and then pick the object itself. So now the object's local pivot is being used not just for moving it, but also for modeling as well. And if I switch to rotate, notice that it's set to its default view, and I can switch this to the box as well. So now both move and rotate are set to box 001, which is the same object. If I want scale to be set to it, I can just select it from here as well. So now what I can do is move it and rotate it. And now it's perfectly planar to the surface and gives me the result I want here. So let's exit out of sub-object level and return back to the object level. And let's say I'll delete the apply modifier. So now if I apply symmetry, I get this result right here, and I can move it like so. But let's say that I reset the X form, utilities, reset X form, and this is very helpful in many situations. And now I'll right click and collapse it, and now it's back to Edward Poly. If I apply symmetry now, notice we get this result right here. And now notice that even though the reference coordinate system is set to local, it still has the same orientation as if it were set to world. Remember that world never changes. So we've reset the X form, which is short for transforms. We've reset the transforms, the rotation scale, back to the default orientation like so. So let's say we want the orientation to be back to where it used to be, and we want symmetry to work how it used to. One thing I can do is create a box, a little helper, and I'll also give this a gray material, and I'll give this a green object color. Just let me know it's a helper object, and I'll make sure that the length, width, and height are all the same. And now what I can do is use the Clavortech Align to Surface tool. And let me turn off symmetry. So I've got this hotkey set to Shift-Alt-A, and I'll position it right here. If I want more accuracy, I can use the 3-point Align tool. So what I will do is click 1, 2, 3, and now here I'll select 1, 2, 3, and now it's aligned. And now what I can do is select this object, activate symmetry, click on mirror, press Alt-A to activate the Align tool, select this helper box, and notice that the mirror has actually moved a little bit to where that box is. However, what we want to do is activate orientation, which is another word for rotation. So we want to activate X, Y, and Z. And now the mirror orientation is the same as the box, which has given us this result right here with the symmetry. And if I want to snap the mirror subobject to, let's say, right here, I'll make sure that vertex is on, activate snaps, and now I'll snap from here to here, and there we are. And now it's perfectly in line with this vertex. Or I can activate flip, activate snaps, and all you need to do is just hover over here, click, and then you can snap to the vertex. And we get this result right here. And now I'll exit out of symmetry, and even though the symmetry issue has been solved here, the object's local pivot, local orientation is still the same. So it's still the same whether it's view, world, or local. And let's say we actually want to change its orientation. Now one thing I can do is to go to the hierarchy, effect pivot only, press Alt A, click on the box, OK, and now notice that the object's local pivot is the same as the box. However, if I apply a symmetry again, notice that its orientation is still how it used to be. Now since we have changed its pivot, we expect it to be aligned right here. One thing to understand is that even though we've changed its pivot, and now we can move it according to its new pivot, and also rotate, for other tools, its pivot is still the same as if it were set to world. If you actually want to change its pivot for all situations, what you can do is actually select the box, the helper box, and simply attach it. And then switch to element and detach it. And now if I apply symmetry, notice how now it has the new orientation. So now the new orientation, the new pivot applies not just to moving, rotating, and scaling, but also to the symmetry tools. So now we've changed the pivot and orientation closer to where it used to be. And now we can use this to move it, rotate it, and scale it. Let's say I want to change the pivot to be in the center and at the bottom here. I will go to hierarchy, effect pivot only, center the object, and now what I'll do is right click on the snap settings, and now I can also activate pivot snap as well. What I usually do is just have the snap settings right here, because I find myself changing to all sorts of different snap settings, sometimes turning ones on and sometimes turning them off. And I'll press S to activate snaps. And what I would also do is under options, I'll activate enable axis constraints. And the hotkey for this is Alt D. So with axis constraints on, first what I can do is enable the Z, X, or Y axis, or a combination of, for example, Y and Z, or X and Y. Right now, Z is enabled because it's the yellow arrow. And what I can do is hover over here, and now I'm snapping to the object's pivot. What I would do is snap the pivot to a bottom vertex right here. So now its pivot is right here. And remember that I'm using the local orientation. If I was using world, it would not be quite working. So I'm using local. So now it's in the center at the bottom, and I can keep it there if I want it there. And let's say that I want the pivot to also be right here. So activate snaps, and now I will make sure that the X axis is active by clicking right here, and now the X arrow is yellow, and now I'll hover over here to select the pivot, and then click and hold and move it right here, snap to this vertex, and then let go, and here we are. And now the pivot is at the bottom, all the way right here. So using these simple tools, you can have control over where exactly your pivot is at all times, and you can use it to model and apply symmetry and other modifiers and make modeling a lot simpler, a lot more intuitive. So just master these simple hotkeys such as Alt D for axis constraints, S for snaps, and just have the grid and snap settings open because you may notice yourself using them frequently. You can also put them on the second monitor if you have it, and that way it won't be taking up space here. So now if I, let's say, copy this modifier, if I select these polygons and attach them as a clone this time, they will still have the same pivot, the same orientation as its parent object. So if I paste that modifier back, or I can just apply symmetry, and remember, symmetry goes to where the pivot is. So since the pivot is right here in the center, and since the orientation is like so, once I apply symmetry, by default it will just be right here in the center with this orientation. So now I can select these edges, pick this object, and continue modeling. And since the pivot is here in the center, what I can also do is apply Y symmetry and get this result here. And this is all done at an angle. So a lot of times the object you'll be working on will just be here in the center. It'll be planar, and sometimes it'll be at an angle, especially when you're working with more complex objects. So it's important to be able to know how to work at an angle. And the helper box is still right here in the center. So remember that I created the helper box right here in the center, and I can always return it to its original orientation by switching to rotation, but notice that now the X, Y, and Z values are all set to 0. What I need to do is switch from local to, let's say, world or view, and now I can simply right click and return it to its local orientation. And since I use this helper box to give me the pivot and orientation for these objects, what I can do here is, let's say, link this object to this, select it, switch to rotation, and now I can also right click here and return it to this orientation. So with these basic tools, you now have a lot more control over how your objects behave, and you can work comfortably at an angle with more complex objects. In the next video, I'll cover more tools and techniques that you can use to help you work with angles. Thank you for watching, and take care.